Hi friends, we are in chapter 4, linear functions and relations, and we're at section 4.4, parallel and perpendicular lines. Just for the record, I think that we can definitely include this section on the exam, so I want everybody to get to this section and make sure they understand. So make sure if you have questions, you're asking me and you're keeping up to date with your work. Let's look at our first set of examples. Oh, let's do vocabulary first. Vocabulary, first of all, we need to talk about what are parallel lines. When we talk about parallel lines in algebra, we're really describing the linear equations, but let's just talk about what parallel lines look like. They look like lines in a plane that will never intersect. They're going in the same direction. When we have equations of parallel lines, what you're going to notice is that the slopes, that they have the same slope. So if I had, for instance, y is equal to 2/3 x plus 3, and another equation is y is equal to 2/3 x minus 17, the fact that the slopes are the same lets me know that these lines are parallel. With perpendicular lines, the situation is different. Perpendicular, by the way, means that the two lines intersect at a point to form a 90-degree angle. That little square is often put at the vertex of a 90-degree, well, it is put at the vertex of a 90-degree angle. So when you see that, know that that's what it means. And so two lines that form a 90-degree angle are considered perpendicular. So perpendicular lines, for algebra's sake, when we're dealing with their equation, are lines whose slopes are opposite reciprocals of one another. That seems like a mouthful and a lot to think about. So I'm going to write down an equation. Let's say I had y is equal to 5x plus 4. The slope is 5. The opposite reciprocal means to flip this number, flip it like, 5 over 1, flip it 1 over 5, interchange the numerator and denominator. So I'm going to flip the number 1/5 and then take the opposite sign. Since this is positive, I want a negative. If I have a line that has a negative 1/5 slope, doesn't matter what the y-intercept is, 725, negative 4053. The reality is that these two lines are perpendicular. So if I were to graph them, they would be perpendicular to one another. We'd have that situation there. So that's what you need to know about the next couple of for the next couple of examples. Let's look at example 1. Parallel lines through a given point. So here we go. We're going to write an equation in slope-intercept form for the line that passes through negative 3, 5 and is parallel to the graph y equals 2x minus 4. So first, we know we're dealing with this form, y equals mx plus b, that's slope-intercept. When we have slope-intercept, we need to find the slope and we need to find the y-intercept. We are given a point and we're given a slope too. See, this line here, we're told that we want the line that we're going to create to be parallel. So that means that we're going to share the same slope. So in a sense, I'm using this line for its slope. So once I find out from this line that its slope is 2, because it's in slope-intercept form, that's all I want from this line. I don't want anything else. In a way, I could actually scratch it out. I'm good. I got what I wanted. I got your slope. So now I'm going to go ahead and do what I usually would do. So the question could read, what is the equation of a line that passes through negative 3, 5 and has a slope of 2? And so we know how to do this. We did this all in the last section. We're going to put 2 times x. Well, let's not use x, right? Let's go ahead and put in the x value. And the x value that we're talking about here would be negative 3, right? We're looking at this point here, plus b, and that's equal to 5. So 5 comes from the y value. So 5 is equal to this. 5 is equal to negative 6 plus b. Move the negative 6 over to the other side by adding 6 to both sides. And we get, I'm going to put an arrow over here, we get that 11 is equal to b. My take home is that the equation is y is equal to the slope that we got from the other line, 2x plus 11. Let's look at another example.